Alright, this is the beginning of section 7.4, special right triangles. And there's a couple different kinds of special right triangles. And when I say special right triangle, I mean basically what it says. Right triangles that have special properties, and they use the Pythagorean theorem, but they're shortcuts. So you can always fall back on the Pythagorean theorem, but these are a little bit quicker and a little bit more handy when we have these two different types of special right triangles. The first one we're going to talk about is a 45, 45, 90, and that's named by its angles. Alright, so when we say 45, 45, 90, we've got obviously the one angle here is 90 degrees. The upper angle is going to be 45, and so is this lower angle, because these two angles are equal, and we know they add up to 90. Divide them by 2, you get 45 degrees for each angle. So let's just write that in real quick. We've got 45 degrees here and 45 degrees here. Okay, so the rules, or the special rules that we have, is it goes like this. If I call this side x, I know that this must be an isosceles triangle because these angles are equal. This angle and this angle are equal, so these two sides, one here and one here, must be equal. Okay, so these sides are both x. And the special relationship is this, that the hypotenuse, it turns out, is x times the square root of 2. Okay, so whatever I put in for x, and I want to find the hypotenuse, I just multiply that number by the square root of 2. Here's a couple formulas that'll help you out here. First one is the hypotenuse is the leg times the square root of 2. So the hypotenuse equals the leg times the square root of 2. Okay, so whatever I put in, if I want to find the hypotenuse, all I need to know is this x, and I can find the square root of 2. And we could even simplify this further and say the hypotenuse equals x times the square root of 2. Whoops. Okay, sorry about that. For some reason my eraser doesn't work. This is the square root here, square root of 2. So all I've done is replace the leg with x. One more formula that kind of comes from this is, oops, we better call this x and x square root of 2. Sorry, not sure where that went. One more formula. This is maybe formula 1, and we can call this over here formula 2. You can write this wherever you have space on the page there. But the other one is the leg. And the leg, if we solve this formula over here, if we solve this for the leg, we would get this equation here. The leg equals the hypotenuse divided by the square root of 2. Okay, so the leg equals the hypotenuse divided by the square root of 2. So those are the two kind of results of this. Remember, the Pythagorean theorem always works, but this is kind of a shortcut to find either the hypotenuse or the leg. Remember too that this triangle is formed by cutting a square in half. So we can imagine that maybe there was another part of a square out here, and this triangle is formed by cutting that square in half. So this is half a square. Okay, so the next theorem that we're going to talk about is the 30, 60, 90 triangle theorem. And it turns out that if we have a 30, 60, 90 triangle, and by that, once again, I mean the angle measure. So this angle measure is 30. This would be 60. And of course, we've got a right angle down here in the lower left. The 30, 60, 90 triangle theorem. And once again, we're going to do like we did with the 45, 45, 90 triangle. We're going to call this short side, this side over here, we're going to call this x. Okay, so if that side is x, then the result from the theorem up here is that the longer leg is the square root of 3 times the shorter leg. So it's x times the square root of 3. Okay? And it also says up here in the theorem that the hypotenuse is twice as long as the shorter leg. So you could probably imagine that if the shorter leg is x, the hypotenuse is 2x. Okay, so this is the relationships in a 30, 60, 90 triangle. We can sum these up in three formulas here, one for the hypotenuse, one for the longer leg, one for the shorter leg. Okay, so I know I kind of threw a bunch of stuff on the screen there, so you might need to pause real quick and jot that stuff down. But the hypotenuse, this first formula, is the hypotenuse equals 2 times the shorter leg. 2 times the short leg. Let's say 2 times the short leg. Okay, right? Once again, if I call the short leg x, the hypotenuse is 2 times that x. Next one, the longer leg, is the short leg times the square root of 3. So same idea. Remember, we can think of this, the short leg here is x, right? So x times the square root of 3. The short leg, this one's a little bit more complicated, but this is simply solving this top equation here, the hypotenuse equation. Solve that for the short leg, and that gives us the hypotenuse divided by 2. Okay, so those are 3 formulas for a 30, 60, 90 triangle. Hopefully at this point, you've got your formulas jotted down for 45, 45, 90, 30, 60, 90. You've got a nice kind of half a sheet of notes there. The rest of the time, we're just going to do examples. So we're going to do probably 3, maybe 4 examples here. You can kind of put in the bottom of the page. And then you should be ready to tackle the section 7.4 homework. Okay, so this is one of the most straightforward examples of a 45, 45, 90 problem. I've got a right triangle here. The 2 legs are 8, and I want to find the hypotenuse. Okay, so like usual, you should pause this, try and figure it out yourself, and then see how you did. Is the best way to go about the notes. So pause it now. Okay. Hopefully you tried it out and you got down to the answer. We're going to kind of analyze it now. Since both sides are 8, I know that this is a 45, 45, 90 triangle because these angles are congruent. And so this must be 45 degrees. And the other angle must also be 45 degrees. Okay, so my theorem says something like this. If I give you a 45, 45, 90 triangle, and I call both sides x, then the hypotenuse is x times the square root of 2. Okay, so in this problem, 8 is my x, right? So the hypotenuse equals 2, I'm sorry, not 2, equals 8 times the square root of 2. 8 times the square root of 2. And you can just leave your answer like that. That'd be fine. Leave the radical. If you'd like to estimate it, that's okay too. But there's no need to estimate it. You can just leave it like that. If you do, it's about I think 11.3. So this would be approximately 11.3 if you did put that into your calculator. So that's the first example. We'll go on to the next example now. Okay, so this is a little bit more complicated problem than the last one. I want to find h again, but what makes it a little bit more complex is that I've got this 3 times the square root of 2 over here instead of 8s. 8s were pretty handy. This is a little bit more complex, but not too much. So I'm going to use that same formula. It says that the hypotenuse equals the leg times the square root of 2, right? Well, in this case, my leg is 3 times the square root of 2. So when I find the hypotenuse, I'm just going to substitute 3 times the square root of 2 times the square root of 2. Okay, and now here, I'm almost done. I just have to simplify. So the hypotenuse equals 3, and the square root of 2 times the square root of 2, when I multiply these things together, I think that I'm just going to get 2, and 3 times 2 is 6. So my hypotenuse is 6. Alright, this example we're going to switch. We're going to use the 30, 60, 90 triangle theorem there at the top of your page. I want to find x and y in this example, and I'm given the hypotenuse. So I want to remind you of a couple things first. At the top of the page we talked about in terms of short leg and long leg. So real quick, my x is my short leg, and y is my long leg of the triangle. Okay, and my formula for the long leg is the long leg equals the short leg times the square root of 3. The problem is that I don't know the long leg, so let's find the hypotenuse first. Alright, so the short leg equals the hypotenuse divided by 2. Okay, so the short leg, once again, is the hypotenuse divided by 2. Well, the short leg is going to be pretty easy to find because that's just going to be 6 divided by 2, which is 3. So I've got that x equals 3. That's half the battle right there. X is 3. Next, I want to find that long leg. Well, and remember, let's do a different color here. Ooh, how about rainbow? All right, oh, I can change. All right, how about, well, I guess let's go pink here. So the long leg equals the short times the square root of 3. Well, now I know my short leg right here, so I can just put 3 in for the short leg, and I get that the long leg equals 3 times the square root of 3. And we can just leave it like that, or we can estimate, and we get down to about 5.2. So, quick recap, we want to make sure in this one we identify our short leg and our long leg. Use those formulas that were given to find the short and the long leg. You don't even have to use the formulas if you can just kind of look at the picture and the diagram and extract the information you need from that picture up there in your notes. But if you do need the formulas, remember, pick the right one and label correctly. Okay, this one we've got a little bit different situation. I've got a triangle here, and I've got the height of the triangle right here is this line going up and down vertically here. And I want to find that height. That's my question. So, real quick, before we even move on, are there any theorems or formulas that we learned today that might help us besides the Pythagorean theorem? We want to use one of those new theorems that we learned. It might be a good idea here to pause it and think about which one we might use and why. Okay, hopefully you've kind of thought about it, but now we're going to look at what theorem to use. If I've got 2 here, and my hypotenuse is 4, well, 2 times 2 is 4, so I think that would mean that 2 is my short leg, and 4 is my hypotenuse. I think that means I've got a 30, 60, 90 triangle. Alright, so once I establish that, yeah, I think this is definitely a 30, 60, 90 triangle, then H becomes my long leg. Okay, so once again I look at this and I see that 2 is half of 4, which remember the short leg times 2 is the hypotenuse, so that's my short leg. Then I know that, and we'll write this down too, that 2, well, that's my short leg. And I want to find H, which is my long leg. Well, I have a formula that says the long leg equals the short leg times the square root of 3. Okay, so from here, once we've identified that we've got a 30, 60, 90 triangle, this becomes pretty straightforward. My long leg is H, right? We said that over here, that my long leg was H. And that equals the short leg. Well, the short leg is 2, we decided, times the square root of 3. And you can just leave it like that. H equals 2 times the square root of 3. You can estimate it if you'd like, but like I said before, this is a more exact, more precise answer. And you can have a shout of joy because you have completed section 7.4 notes and you're ready to go on to the homework. So, good luck, and we'll see you in class tomorrow.